for exploring mathematics. And we want students to have access to that not just in the classroom, but also at home. A lot of math learning continues at home or outside of the classroom. And we felt like if students have to shell out $100 or $150 to have access to those tools outside of the classroom, that's frustrating to us. That's a disappointment because that restricts access to tools that can support learning and support opening doors in the future. And as we built these tools, we've heard time and again from teachers, not so much from students, but I imagine that they would echo these sentiments if they were thinking about the assessments as well, that it's a bummer that what we think are the best tools for learning mathematics, suddenly you have to change gears and use a different set of tools for expressing your learning of that mathematics. So when it comes to assessment time, it was always a bummer for us that students didn't have access to Desmos if they were using Desmos to learn. And so we've started partnering with states and assessment organizations to change that. So now that students can use Desmos both in the classroom and at home and also on assessments. And that all fits in with that mission that we would help every student learn math and love learning math. So just a big picture question of why does Desmos care about assessment? It's about equity, it's about access, it's about supporting teachers and students and allowing them to have the best tools available, both when they're learning and also when they're taking their assessments. So there's the preamble. Let me jump into what's going to be my favorite part of our time together, which is showing off some of these tools. And I'm going to start with the scientific calculator. So again, if you just go to desmos.com, we've got access to the graphing calculator, four-function, scientific, and then some other resources that we won't get into on this particular webinar. At the end, I'll talk briefly about the one or two differences you'll see between Desmos as you'll find it here. I'll call it the plain vanilla version of Desmos and the version that students will encounter on the North Carolina assessments. Small set of differences, nicely documented for you. I'll point you to that resource at the end. But for now, let's jump in. Let's take a look at the Desmos scientific calculator. Then we'll hop back and look at the four-function and jump forward and look at the graphing calculator. So first things first, you can do some simple arithmetic like 1 plus 2. You can hit return here on the bottom right. You can make things just a little bit bigger and easier to see if you're collaborating with, say, a classmate at the table or just need to see those numbers a little bit bigger, or maybe you're doing a webinar and sharing your screen. In addition to being able to enter expressions on that built-in on-screen keypad right here, so 2 plus 3 times 4, and then return. If I have a physical keyboard attached to my device, I can also enter things here, like 5 minus 2 times 1. And hit return, and I get a new line. Notice that Desmos updates on every keystroke, so if I go back to one of these expressions, I can change that 1 to a 3, and immediately we see that result change to a negative 1. Or maybe I wanted to change this 5 to a 15, and automatically we see that result update on the right immediately. So you can enter results, you can enter expressions on the built-in keypad. For just a moment there, I was entering things on my physical keyboard. I showed off how you can edit expressions. Here's another thing that I really love, is that you can call on the previous answer and use it in your next calculation. So if you just mash this A and S button here towards the bottom left of the built-in keypad, we'll bring in this A and S to say that we're pulling that answer from the previous line, but we also show the value of that expression. That's 9, and then I can do other things, like maybe I want to raise this to the second power, so I'll press my A squared button right there. Might hit return, might want to call this answer and say divide that by 2. Anyway, you could go on and on. One of the things that I love about Desmos, and it's true for all three of the calculators we'll look at here, is that math tends to look in this tool the way it looks on paper or the way it looks in a nicely formatted textbook. Exponents look nice. All of these operations look nice. Fractions are formatted as fractions. Another thing that I want to call out is that you can edit an existing expression in a few different ways. So one of the things is you could delete an individual character. So if I just press this backspace button here, if I continue deleting, I'll move through that entire expression. Another thing that I can do is if I press this clear button, in one click I can wipe out an entire expression row. And then if I have a blank expression row, I can clear everything. Maybe I just wanted to start fresh and explore a new problem without reloading Something else to call out here, I already showed off how to use the squared feature, but maybe you want more flexible exponents, like 3 to the 4th, you just press 3, and then this A to the B button, and then whatever exponent you want. In this case, I'll put down a 4. Or, if you like physical keyboards, students can hold Shift and press 6. So here's 7 to the 2nd power. And you can't see my hands moving across my physical keyboard, but again, Shift 6 is how you can move the cursor to the superscript where that exponent goes. You can also enter square roots either here on the keypad, so let's take the square root of that answer and we get back to 7, or there's a few keyboard shortcuts. Again, if you prefer that physical keyboard, you could type SQRT and we'll interpret that as, oh, that's a square root symbol. So we'll fire one of those up for you and you can take the square root of 49 or 64 or whatever it is that you'd like to take the square root of. I showed it off earlier but didn't call attention to it, that you can enter fractions simply by hitting the division key here or the / on your keyboard. So you might do something like 1/2, and then I'll press the right arrow on my keyboard to get out of the denominator, plus 1/3. And we've got the decimal representation of that result there on the right. Other functions are available here, either if you know the keyboard shortcut or if you poke around some of the other menus. So you can switch from this main kind of numerical plus the go-to functions that are built in over to a QWERTY keypad. That's one difference actually you'll see on the actual assessments, is it's an ABC keypad. And we have some common functions tucked away here as well. And I want to call attention to one of the design principles that you'll see both right on the screen now and also in the graphing calculator especially, is that we design the tools to be friendly to a wide range of students. So not all students are ready to explore logarithms or absolute value or the exponential curve or the nth root of something. And so we tuck some of the more advanced functionality just behind that first layer so that it's a little more friendly and intuitive experience for students depending on what math they're exploring. And then we built the tool to grow with students so that when they do get into those more advanced concepts and advanced functionality, that it's all right there for them. So that's all I want to show off in the scientific calculator. And then just a quick tour of the for function. And I assume folks may have some questions along the way. And if you could jot those down or even punch them into the webinar tool, we'll circle back and move through those during the Q&A time. So let's take a look at the for function calculator. And I just want to spend a few seconds here and just highlight the fact that the design interface is basically a carbon copy of the left side of the scientific calculator when you have the keypad on, or the default, the main keypad. So we've got the numbers, we've got the basic operations, we've got that answer key. A couple other things like grouping symbols, square root is tucked here at the top. And our goal is that students who are familiar with the for function, as they roll into more advanced tools and needing the scientific calculator, that everything they learned about using this version of the Desmos calculator pays off as they use this version of the Desmos calculator. So that's all I wanted to show off for the for function. And now sort of the main event. This is kind of where everything started for Desmos, and you'll find the most power and maybe have the most questions, and that's the graphing calculator. So first thing I'm going to do to make it easier for folks to see is click the graph settings icon here on the top right, and we'll go projector mode. The graph paper gets a little bigger, bolder, easier to see. The expression list here on the left gets a little bit easier to see. And now I'm going to do most of my typing on my physical keyboard, but I will call attention to the fact that we have, again, this familiar on-screen keypad. That if you're familiar with the other two calculators, this center part right here, you'll feel right at home. We've got some common functions and common characters, and then more functionality tucked away in this menu right here. But I'll hide that so that I can do a number of things with my built-in keyboard. That's the way I'm most familiar with using Desmos. And first thing I want to show off is that you can plot points in Desmos. So I'll graph, say, instead of 3,2, we'll go with 2,3. And on the next line, I'm going to plot 4,6. And on the next line, I'll plot 6,9. And let's do one more. Let's do 8,12. Now I can see the red and the blue points. Again, the Desmos graphic calculator updates on every keystroke, just like the Desmos scientific calculator. I can toggle these points on and off. I can click to reveal their coordinates. I can add a label to have those coordinates show up more permanently. But I've got one big issue here, which is I can only see half of what I plotted. Now, one of the things I love about the Desmos graphing calculator is it sort of behaves the way you would want paper to behave, which is just, if you can't see something, maybe you just need to click, hold, and kind of slide it to adjust your view. And now I can actually see all 4 of the points that I plotted. You can zoom out, zoom in, hit that home button to get that original view, or I actually liked it quite a lot just like this. I can primarily focus on this first quadrant of the graph. Another thing that you can do in Desmos is plot maybe not one point at a time. Maybe we want to plot a bunch of points all at once. So I'm going to click this plus button. This is our add item button, and it's just above the expression list on the top left. And I'll select this third option here, and that's table. And I'm going to plot the same points, so 2, 4, and then I'll scroll down slightly. I want you to watch what happens, and you have to take my word for it. I'm about to press just one button on my physical keyboard. I'm going to press return, or maybe it's enter on your keyboard. And watch what Desmos does. It gives us a 6 automatically, and an 8 automatically. So students are exploring scatter plots or exploring patterns with data, organizing that in a table. We try to make it easier and interpret what it is that students are doing. So maybe I'll mash that out a couple more times, and now I've got 2 through 12 with a step size of 2. And let's see, we had 3, 6, 9, 12, and 15. I think I will zoom out just a little bit more to see all of those points. I don't need these original points anymore, so I'm going to get rid of those. Now, just in case you go too far, you can do this in any of the calculators, and you can just simply undo your last move. I kind of wish in real life sometimes I had like the ability to control time, and in Desmos to some degree you do. You can toggle back and forth through your latest moves. And I realized I forgot that last row on the table. Let's put 18 there. Another thing you can do in Desmos, other than plotting points either one at a time or all at once in a table, is you can plot lines. And here you'll see that updates on every keystroke result again. Maybe that purple and that blue are a little too similar in color, so I want to actually change this to red. Possibly more helpful as someone is exploring mathematics rather than finding an answer to a question they're being assessed on. But all of these style options here can be quite helpful in the classroom. Change the style, change the color. I'll go with a solid red line here. And then I noticed that my line doesn't pass through my points. I want it to be steeper, so I'll change this to a 2x, a 3x. Actually, none of those are any good. Back to a 1, a 2. That's too high. What if I go with 1.2, 1.3, 1.4, 1.6? Yeah, no dice here. One other thing I could do, although some of you folks watching may know exactly what number I need there, I can enter a letter instead of a number, where I might have entered, say, a slope of 1 or 2 or 3. I'll put K, or maybe you'd put N or A. Desmos doesn't know what to do with K, so it suggests maybe you want a slider. And I can click this blue button to add a slider, and now I can manipulate dynamically and watch the graph update in real time. Earlier, I feel like we discovered that the right slope is somewhere between 1 and 2, and now I get a little more fine-tuned control. In fact, if I drag it right there, it looks like a slope of 1.5 will do the trick. In fact, I can go up to my table and add another column and say, yeah, what happens if we do 1.5 times that first column, and we get those same values, the green points and the blue points match. So that's just a quick tour of Desmos from a points, tables, and lines perspective. We saw that the graph paper, again, updates on every keystroke. You can rearrange the viewing window with relative ease. And we also saw the use of sliders to figure out our exact slope value here. Desmos is good for a lot more than just lines, though. So you can also plot curves. Let's go with a rather common curve, like maybe a downward-facing parabola. And maybe 4 is not big enough. I've got a little more on my viewing window. Let's take this out to an intercept to be nice and friendly. Actually, no, I want an intercept not to be nice and friendly. Sorry for the indecision there. And now I've got my line, and I've got my curve. I don't actually want to see the individual points on the line anymore. And I'd really love to know a few things. What's the maximum of that vertex? Where do my line and my curve intersect? What are the x-intercepts of all of these things? And I don't know what other mathematical tools you folks use with your students.